Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized conversations.
Today, we're diving into a topic that sounds like it's straight out of a sci-fi movie. Can AI models hack?
Exactly. We hear a lot about using AI for cybersecurity defense, like finding bugs or spotting intruders. But this new caper asks the opposite question. How good are the world's most advanced AI models at offensive cyber tasks?
To figure this out, the researchers didn't just ask the AIs to hack the planet. They needed a standardized test, so they turned to something called Capture the Flag competitions, or CTFs.
And what exactly is a CTF? Is it like the gym class game but with keyboards?
Almost. Think of it as a digital obstacle course for ethical hackers. They're given a series of challenges, like cracking a code, finding a vulnerability on a website, or reverse engineering a program. And the goal is to find a hidden piece of text called a flag. It's a way to test and prove your hacking skills in a safe, legal environment.
So the researchers basically had the AIs sit down and take a hacker's final exam. They used a set of 200 of these challenges from New York University, a really comprehensive benchmark.
Right, and they didn't just use a standard chatbot interface. They set up AI agents. An agent is more than just a chat partner. It's an AI that can actually take actions. It can run commands, use software tools, and analyze the results.
The paper describes a really interesting setup for these agents, a planner-executor architecture. It sounds very official.
It's a great analogy for teamwork. Imagine a heist movie. The planner AI is the mastermind, the character who looks at the whole problem, comes up with a high-level strategy, and breaks it down into smaller steps.
And the executor AI is the specialist on the ground who actually carries out the tasks. The planner says, we need to get into the vault, and the executor figures out how to use the tools to crack the safe, reporting back on its progress.
Exactly. With this setup, the researchers started changing variables to see what really made a difference, and the first thing they tested was the AI's toolkit.
Right. They compared two different operating systems. One was a standard operating system called Ubuntu, which has some basic tools. The other was something called Kali Linux.
And Kali Linux is basically the Swiss Army knife for cybersecurity professionals. It comes preloaded with over 100 specialized hacking tools. It's the difference between giving a chef a single pot and a knife versus giving them a fully stocked professional-grade kitchen.
And that difference was huge. This is the first major finding. Just by giving the AI agent the Kali Linux environment, its success rate at solving the challenges jumped by nearly 10 percentage points.
That's a massive improvement, and what's fascinating is that this well-stocked toolbox was far more important than the other thing they tested, fancy instructions.
This is what's known as prompt engineering, the art of carefully crafting your instructions to get the best performance out of an AI. The researchers tried giving the AI super specific tips, and also an auto-prompting mode where the AI would first explore the problem and then write its own starting prompt.
And the result was it mostly backfired. In fact, in the well-equipped Kali Linux environment, these extra tips and prompts actually made the AI perform worse.
How can giving it more help make it worse?
The paper suggests it's like over-constraining an expert. If the AI has all the right tools, giving it very specific instructions can just get in the way and limit its ability to find the best path forward. It's like telling a professional race car driver the best line through a corner. They already know, and your help is just a distraction.
So the lesson here is tools over talk. Give the AI a great workshop and then get out of its way. Okay, so now for the main event. Which AI was the best hacker?
They tested 10 of the top models from providers like Google, OpenAI, and Anthropic, and there was a very clear winner. Taking the top spot was Claude 4.5 Opus, which solved an incredible 59% of the 200 challenges.
Wow, nearly 60%. That's seriously impressive. Who came in second?
In a strong second place was Google's Gemini 3 Pro, solving 52%. After those two, there's a pretty big drop. The paper makes it clear that these two frontier models are really in a class of their own right now.
Is the best also the most expensive?
It is. Claude 4.5 Opus was the priciest, but the researchers also identified a best value option. That was Gemini Flash. It only solved 27% of the challenges, but it did so at a tiny fraction of the cost, just 5 cents per solved challenge. So if you're on a budget, Flash is your AI.
That's a great cost-performance analysis. So one last experiment. What about that planner-executor heist team? Did it help to mix and match the AI models?
You mean like using the super smart, expensive Claude Opus as the planner and the cheaper, faster Gemini Flash as the executor?
Exactly. Get the best of both worlds, a brilliant strategist and an efficient worker.
The researchers tried that, and it was a terrible idea. Performance tanked. The asymmetric teams, where the planner and executor were different models, performed much worse than teams where both roles were played by the same model.
Why would that be?
The theory is that the models just aren't on the same wavelength. A planner from one company might give instructions that an executor from another company just doesn't quite understand or interpret correctly. There's a coordination inefficiency. The best results came from a homogeneous team, 2 Gemini 3 Pros working together, for instance. They share the same underlying logic, so the communication is seamless.
So, to sum it all up, if you want to build an AI agent that's good at a complex technical task, this research says you should focus on 2 things. First, give it the best possible environment and tools. And second, choose the most capable model you can.
And what you shouldn't be wasting your time on is overly complex prompting or trying to create a mixed and matched team of AIs. Simpler is often better. Let a capable agent with great tools do its thing.
Of course, this all brings up the dual-use problem. The same AI capabilities that could be used to find security flaws for defensive purposes could also be used by malicious actors to automate attacks.
Absolutely. And that's why this kind of systematic benchmarking is so important. It gives us a clear, transparent measure of what these models are capable of right now, which is essential for understanding and preparing for the future of both cybersecurity and AI.
A fascinating look into the world of AI hackers. That's all the time we have for today.
Thanks for tuning in to Daily Papers. We'll be back next time with another deep dive into the latest research.